August 17th, 1969. 11:30 at night on the Mississippi Gulf Coast. The most powerful hurricane ever measured on approach to the United States is coming ashore in darkness. That afternoon, a reconnaissance aircraft flew into its eye and radioed back a central pressure of 901 millibars, a number so low that forecasters checked it twice, because almost nothing in the historical record compared to it. The winds around that eye are estimated near 190 miles per hour. Estimated because the instruments built to measure them are failing inside the storm. And ahead of the eye, the Gulf of Mexico itself is standing up, a dome of ocean that will come ashore higher than any storm tide ever recorded in the United States. 24.5 feet. The man responsible for warning the nation runs the National Hurricane Center. Tonight he has a problem no forecaster has ever faced so starkly. The danger is real, the data is in his hands, and the language to make ordinary families understand it does not exist. There is no such thing in August of 1969 as a Category 5. There is no scale. There is only the word hurricane, the same word used for storms 1/10 this size. By morning, the towns in front of this storm will be, in places, erased down to their concrete slabs. And yet the deadliest hours of this disaster will not happen here, and not tonight. They will happen 2 days later, 900 miles away, in mountains where no one was ever warned at all. This is the story of Camille, the storm that was too strong to measure, too big for the language of its era, and the reason a category scale exists every time you hear the words Category 5 today. Camille's entire life as a monster lasted barely 3 days, and that speed is the first thing to understand about it. On August 14th, it was a tropical depression west of Grand Cayman, one of the season's routine disturbances. On the 15th, it was a hurricane. It brushed across the western tip of Cuba, weakened slightly over the land, and slid into the Gulf of Mexico. And there, it found the one feature of that body of water capable of building the storm it became: the loop current. The loop current is a deep river of tropical water that bends up from the Caribbean into the Gulf before curling back out toward Florida. What matters is not just that it is warm at the surface, it is warm hundreds of feet down. That depth changes everything, because a hurricane normally carries the seed of its own weakening. Its winds churn the sea beneath it, dragging colder water up from below, and that cold upwelling starves the engine, a built-in brake that keeps most storms in check. Over the loop current, the brake is gone. Churn the water as violently as you like. What rises from below is more warm water. The furnace refuels itself faster than the storm can exhaust it. Over that deep heat, on August 16th and 17th, Camille did the thing forecasters fear most. Meteorologists call it rapid intensification, a storm gaining strength faster than warnings can keep up with it. The eye contracted into a tight, small ring, which concentrated the storm's fury the way narrowing a nozzle sharpens a jet of water. The central pressure fell hour after hour, and each reconnaissance flight came back with numbers worse than the last, until the reading of 901 millibars on the afternoon of the 17th, at the time, among the lowest ever measured in an Atlantic hurricane. It is worth riding along on one of those flights, because in 1969, they were the only eyes that mattered. The satellites of the day photographed a hurricane as a white smear. The numbers came from crews who flew a 4-engine aircraft directly into the eye wall, the rotating ring of the storm's most violent wind. On instruments, in cloud, being thrown hundreds of feet up and down in seconds until the aircraft punched through into the eye itself. crews described the inside of Camille's eye, the way climbers describe a summit, a stadium of cloud, walls towering on every side, sea surface boiling below. In there, they measured the one number that cannot lie about a hurricane. Wind readings bounce and gust, but the central pressure is the storm's bare engine gauge, and a barometer does not exaggerate. When the instruments read 901 millibars, there was no ambiguity to hide in. The crew radioed a number. The forecasters on the ground understood, better than anyone alive, that the Gulf Coast's worst night in a century was now roughly 12 hours away. Then, the record simply stops. In the most violent parts of Camille, the sensors meant to capture the peak winds were pushed past their operating limits and failed. The honest answer to how strong was Camille at its worst is that nobody knows. The storm destroyed the act of measuring it. Decades later, scientists reanalyzed every surviving scrap of data and settled on an estimate of about 175 miles per hour at landfall, with gusts likely well beyond 200. But those are reconstructions. The true number went down with the instruments. Camille remains one of only a handful of storms in history to reach the American coastline at the top of the scale that would later be invented to describe it, and the second strongest landfall the United States has ever recorded, behind only one storm from 1935 that we will meet at the end of this story. While the storm was breaking records over the Gulf, the forecast was pointing at the wrong state. Forecasting in 1969 ran on three thin sources: pressure readings from ships, coarse black and white satellite photographs in which a hurricane was a smudge of cloud, and the crews who flew into the storm itself. There were no computer track models worth the name. So through August 16th, the official expectation carried Camille toward the Florida Panhandle, a full state to the east of where it would actually strike. Families in Florida boarded windows. Families in Mississippi watched the news and went to bed. Only on the 17th itself, landfall day, did the picture swing west, and Mississippi's coast woke up to the discovery that the strongest storm of the century was now aimed at it, with less than a day on the clock. What happened in those hours is the reason this story's death toll, terrible as it is not several times larger. Civil defense officials along the Mississippi shore, men like Harrison County's director, who had spent years preparing for a day exactly like this, threw everything at the evacuation: radio, police loudspeakers, knocking on doors along the beachfront. And the coast, to a remarkable degree, moved. Tens of thousands of people left the shoreline in an afternoon. Where the evacuation reached, it worked. Nearly everyone who drove inland that evening lived. Picture what evacuate physically meant in 1969, because none of today's machinery existed. No phone alerts, no live radar in every pocket, no interstate contraflow. Warning a coast meant AM radio bulletins on the hour, police cruisers rolling the beach road with loudspeakers, volunteer firemen and church phone trees passing the word house to house, and civil defense men reading street maps under dome lights, deciding which low neighborhoods to knock first. Persuasion happened face to face, on porches, in the heavy heat of an August afternoon. One official, one skeptical family at a time, with the Gulf still looking calm behind them. That machinery, hand-cranked as it was, moved a coastline in half a day. It remains one of the most effective evacuations of the pre-digital era, and it was carried out by men who could not show anyone a forecast cone or a category, because neither had been invented. But an evacuation on one day's notice collides with human arithmetic. The benchmark for bad on this coast was Hurricane Betsy 4 years earlier, a giant storm and survivable. Thousands of families had ridden it out and remembered doing so. That memory now did quiet, lethal work. When officials said, "This one is worse," what listeners heard was worse like Betsy, maybe a little more. Nothing in anyone's lived experience contained a Camille, so the mind rounded it down to the largest thing it had seen. Psychologists have a name for this, anchoring to experience, and August 17, 1969, is one of the clearest cases in American history of that bias killing people. It was not recklessness, it was memory, doing exactly what memory does. And in Pass Christian, directly facing the Gulf, stood the place where that arithmetic came due. The Richelieu Manor Apartments, 3 stories, solid brick, widely regarded as one of the sturdiest buildings on that stretch of shore. Sturdy enough that it had a reputation as a place to shelter. About 24 people stayed in it that night. Some were simply exhausted. They had spent the day boarding neighbors' windows and carrying furniture upstairs. And by nightfall, the roads were emptying, and the building felt like the reasonable choice. Brick walls, high floors, a structure everyone called safe. The sea that was coming had no opinion about reputations. Camille's eye crossed the coastline near Waveland and Bay St. Louis at about 11:30 that night, with a landfall pressure of roughly 900 millibars. To this day, the second lowest ever measured at a United States landfall. That pressure number is worth 30 seconds because it is not trivia. It is the mechanism of what happened next. Air has weight. It presses down on the sea. A reading of 900 millibars means the storm had hollowed out roughly 1/10 of the atmosphere's normal weight above its core. And where the air pushes down less, the ocean literally bulges upward, a mound of sea raised under the eye and dragged along with the storm. Stack on top of that the wind, which had spent days shoveling the upper ocean toward the coast, and aim the whole thing at the Mississippi Sound, a shallow shelf of water penned between the mainland and a chain of low barrier islands, with nowhere for an arriving ocean to drain. The Sound is, in effect, a bathtub with the coast as its rim. Camille poured the Gulf of Mexico into it, and understand why, in every hurricane, it is the water and not the wind that does the killing. Seawater is roughly 800 times denser than air. A 170-mile-per-hour gust strains a house. The same energy carried in moving water dismantles it. 2 feet of flowing sea will float a car. 6 feet exerts more force on a wall than any wind the atmosphere can produce. When engineers examined the Mississippi coast afterward, the fingerprint was unmistakable. Wind had taken shingles and windows, but everything that was erased, the vanished mansions, the missing blocks, had been taken by moving ocean. The wind is the storm's voice. The surge is its hands. At Pass Christian, the water reached 24.6 feet above normal, the highest storm tide ever measured in the United States up to that night. Not waves, the standing level of the sea, 2.5 stories above the streets, with battering waves riding on top of it. The coast experienced this almost entirely in darkness. Power failed early. The wind rose past anything a living resident had heard, and then the ocean came through the towns. Beachfront mansions that had stood since before the Civil War were separated from their foundations and dissolved into the debris field. Tugboats and barges were carried across the beach highway and set down among houses. And on the far side of the Sound, the storm performed one act of pure geological violence. It cut Ship Island, a single barrier island on every chart for 2 centuries, into 2 islands, blasting a channel of open water through its middle. The gap is still there. Mapmakers had to redraw the coast because for a few hours, Camille had been the strongest force of erosion on planet Earth. Inside the Richelieu, the people who had trusted the brick retreated upward as the sea climbed the stairwells. First floor, second, third. And then the building that was supposed to outlast any storm on this coast met a column of ocean taller than itself. The Richelieu did not flood. It was demolished, swept so completely that by morning its site read as a bare slab. Of the roughly 24 people inside, most did not survive. The handful who did rode wreckage through the night. One survivor's later account of clinging to debris for hours as the sea carried her inland became one of the most famous stories of the storm. It also became something else, and this matters. Within days, a legend attached itself to that slab, that the people of the Richelieu had thrown a hurricane party, that they had died toasting the storm that killed them. The story was irresistible, a morality tale with a body count, and it was repeated for decades in newspapers, in books, by officials who should have checked. The survivors and the victims' families spent those same decades saying it wasn't true. There was no party, only tired neighbors in the strongest building they knew. The myth endured anyway, because a story about recklessness is more comfortable than the truth. That the people in the Richelieu made a defensible decision with the information their era gave them, and died because the information was not enough. The party legend let everyone else believe that the dead had volunteered. The truth is harder. They simply lived before the scale existed. That is what this channel means by an institutional failure. Not a villain, a gap. And the gap had a body count on both sides of it. The people who stayed because hurricane was the only word on the radio, and the reputation of the dead, rewritten to make the living feel safe. Daylight on August 18th did not reveal damage. Damage implies something left to repair. Along miles of the Mississippi shore, the first light showed bare concrete slabs in neat rows, the floor plans of vanished houses, swept so clean that survivors walking their own streets could not tell whose slab was whose. The live oaks that remained were hung with the contents of homes, clothing, bedding, splintered furniture lifted into the branches by 20 feet of sea. A church that had anchored past Christian for a century was gone to its foundation. Ocean-going vessels sat in residential streets, a quarter-mile from water. 143 people died along the Gulf Coast that night. Behind that number sits the one that proves the evacuation's worth. In the blocks where people left, the death toll was near zero, and where they stayed, it concentrated. The line between the living and the dead on August 18th was, almost perfectly, the line between who had driven inland and who had trusted a building. The nation exhaled. Relief convoys rolled south. The cameras counted the slabs, and the Weather Bureau tracked Camille's remnant inland as it did what every landfalling hurricane does: spin down, weaken, and dissolve toward nothing. Within a day, it was a tropical depression over Tennessee, a rainstorm with a famous name. The disaster, by every official and public measure, was over. There is a detail of timing that frames this whole summer. Camille struck 29 days after Apollo 11. The same country that had, 4 weeks earlier, navigated 2 men to a landing on the moon and measured their descent to the foot could not tell you the wind speed inside a storm 200 miles off its own coast, and had no scale on which to report it if it could. That is not a joke at 1969's expense. It is the honest state of the science. Humanity in that summer could reach another world more precisely than it could describe this one. The relief effort mounted in the days after was, for its era, enormous. Military engineers, the Red Cross, convoys from across the country clearing a shoreline where the debris of entire towns lay in windrows, and every man working those ruins did so under the same vocabulary problem the forecasters had. No one could yet say, in a single agreed word, what had just happened here. The storm had one more thing to teach, and it had chosen its classroom. Here is the property of hurricanes that 1969 did not respect, and that still kills people today. The wind dies over land in hours. The water does not. A hurricane is, among other things, a cargo vessel. It carries an ocean's worth of evaporated seawater in its clouds, and losing its winds does nothing to empty that hold. Camille's remnant drifted northeast for 2 days, across Tennessee and Kentucky, raining but unremarkable, its cargo mostly intact. Then, on the night of August 19th, it turned east into the Blue Ridge Mountains of Virginia, and 3 things intersected in the dark over a rural place called Nelson County. The remnant's tropical moisture, a weather front wringing that moisture out, and the mountains themselves forcing the whole air mass upward, which is the one thing you can do to wet air to make it surrender everything it carries at once. What fell on Nelson County that night was not a storm in any sense its residents had words for. In roughly 8 hours, parts of the county received about 27 inches of rain. Gauges in places suggested more than 30, which is more water than that region normally sees in half a year, delivered between midnight and dawn. Survivors' descriptions all reach for the same impossible image: air you could drown in, rain so dense that breathing outdoors felt like inhaling water. And here, this story becomes geology, because saturated mountains do not merely flood, they move. Soil holds together through friction between its grains. Fill every void with water, and the pressure pries the grains apart until a hillside is no longer a solid, but a heavy liquid. Across Nelson County that night, whole mountainsides liquefied and let go at once. Debris flows, walls of mud, boulders, and shattered forest moving downslope at highway speed into the hollows where people were sleeping. Creeks that a child could wade rose into rivers in minutes and dismantled the valleys they had carved. No warning of any kind preceded this. Not because a warning failed, because none was ever conceived. The hurricane was officially dead. The bulletins had ended. The danger had been filed away with the Mississippi coast 600 miles behind. The people of Nelson County went to bed on August 19th, unaware they were in a disaster at all, and 113 of them, roughly 1% of everyone in the county, did not live to the morning. Entire families were carried away together. Some of the missing were never found. The county buried neighbors without knowing the full count for weeks, because every road and bridge that could carry help had gone down the mountains with everything else. Why was there no concept of this danger? Because in 1969, hurricane science was, in an almost literal sense, a coastal discipline. The entire warning apparatus, the recon flights, the tide gauges, the evacuation doctrine, pointed at the shoreline, because that is where hurricanes had always most visibly killed. Rainfall was treated as the storm's aftermath, not its weapon. Nelson County rewired that assumption permanently. The meteorologists who reconstructed the night established it as one of the most extreme, short-duration rainfall events ever documented in the United States, and it became a founding case for a science that barely existed before: inland flood and debris flow forecasting for dying tropical systems. And the mountains keep the evidence. Walk the Blue Ridge slopes above those hollows today, and you can still read the 1969 debris flow scars in the forest. Long vertical seams where the regrown trees stand younger and paler than the woods around them, a stripe for every hillside that moved that night. The county has carried the memory for over half a century. Geology will carry it for 10,000 years. Add Virginia to the coast, and Camille's toll passes 250. The storm that defined coastal catastrophe killed more people in the end, where no one could see the ocean. Every disaster in this series leaves an institution changed. Camille left behind an entire language. The man who had run the National Hurricane Center through that August was a meteorologist named Robert Simpson, and he came out of 1969 carrying the problem of the Richelieu and the problem of Nelson County in the same hands. He had known what was coming, and the knowing had not transferred. The bulletins of the era could say, "Great danger," words that meant one thing to a forecaster reading 901 millibars, and something far smaller to a family who remembered Betsy. Around the same time, a structural engineer named Herbert Saffer had been grading for the United Nations what hurricane winds of different speeds actually do to buildings. Simpson took Saffer's engineering ladder, bound it to the meteorology, and together they produced the thing 1969 had lacked, a scale of 1 to 5, in which each number is a plain language sentence about your house. By the early 1970s, it was in use. Within a few years, it was how America talks about hurricanes. Every Category 4 you have ever heard on a newscast is the direct descendant of the night the Richelieu went down, and Camille was written into the new scale as the benchmark of its ceiling. This storm is what 5 means. What made the scale work was that each number was written as a sentence about consequences, not a statistic about wind. A 1 says, damage to roofs and trees. A 3 says, your neighborhood will be uninhabitable for a time. A 5 says, in the scale's own original spirit, complete failure of structures, do not plan to have a house. That translation, from meters and millibars into the fate of a building, was Saffer's engineering contribution, and it is precisely the sentence the Richelieu's residents never got to hear. Read the scale's top line today, and you are reading, in effect, the Richelieu's epitaph, written as a warning label. The scale did not solve everything. No single number can carry a storm's size or its rain, and Nelson County's particular lesson took longer, seeding the slow build-out of inland flood forecasting that continues today. But measure the change this way. In 1969, the strongest hurricane of the century arrived with 1 word of vocabulary. By the next generation, a family 1,000 miles from any coast could hear 1 number and know. 2 footnotes close the file on Camille. Its name was retired. There will never be another Hurricane Camille, a courtesy the naming system reserves for storms that have killed enough to own their name outright. And its records did not all survive the modern era. In 2005, Hurricane Katrina came ashore on this same stretch of Mississippi, over the same towns, the same slabs, in some cases the same families, and pushed the sea even higher than Camille had. The ceiling of 1969 held for 36 years. That is the quiet warning underneath the entire scale. 5 is not the top of what nature can do. It is only the top of what we had seen when we drew the chart. Because Camille was only the 2nd strongest storm ever to strike this country. The strongest hit Florida in 1935, a hurricane so violent it derailed the rescue train sent to save its victims, hundreds of World War I veterans among them. That's the next story. Subscribe, and it'll be waiting for you.